All right, hi folks, this is Larry Mussolino. I'm recording a short video for um, the homework in our last week 9 of the course, and it has to do with chapter 26. So let me come over here to our textbook, and I want to come here to section 26.1. And here's one formula that's very useful. It says if you want to know a velocity function, the velocity function, we could think of it as v of t because the velocity is going to depend on time. You know, think about you driving in your car. As you change velocity, that velocity depends on time. Imagine you're merging onto a highway. Well, if you're merging onto a highway, your velocity is increasing over time. So the velocity is the integral of the acceleration function. Okay, so there's going to be a question that's going to ask you to find the velocity after a certain amount of time, knowing the acceleration function. So one thing you have to know here is that when an object is free falling, so notice here it says the velocity of a falling object. When an object is falling, let's say I throw a ball off of a building, the acceleration it's going to experience is negative 32 feet per second squared. What that means is every second, the velocity is changing by 32. The negative sign is a way to indicate that the acceleration is in a downward direction. So acceleration is a directed quantity, meaning we can think of it as a negative. Negative acceleration means the acceleration is in a downward direction. All right, so let's go to my math lab, and we could do a quick example from my math lab. Let me see here. Yeah, let's go to number 1. It says here, what's the velocity of a sandbag 2.5 seconds after it's released from a hot air balloon? So you can imagine here's the hot air balloon, right? That's flying, and it releases a sandbag. And of course, the sandbag is going to accelerate due to gravity at negative 32 feet per second squared. It wants to know after 2.75 seconds, let's say that happens right here. At this point, it's 2.5 seconds later. What is the velocity at that point? Now it's going to turn out we're going to use a negative sign for the velocity also to indicate the velocity is in a downward direction. So we call velocity acceleration vectors. Vectors mean they have both a magnitude and a direction. All right, well, to answer that, I'm going to use that formula that says the velocity is the integral of the acceleration dt. But we know the acceleration, that's negative 32. Well, this is a simple integral. You might remember the integral of just a constant dt is taking that constant times t. For example, the integral of 3 dt was just 3 times t. So that means our integral from the integral of negative 32 is going to be negative 32t. But now this is really an equation. I have to add a constant of integration. So the velocity is negative 32t plus a constant. Well, I can figure out this constant because I can use the fact that the initial velocity at time t equals 0 was 0, because when I first dropped the sandbag out of the balloon, it had no velocity, it had 0 velocity. So that means that the initial velocity is 0 when the time was 0. Well, that makes it easy that c equals 0. So my equation is v is negative 32t. So if you want to know the velocity at any time, take that time and multiply it by negative 32. Well, in our example, it's telling me the time is 2.5 seconds. So I'm just going to multiply this negative 32 times 2.75 on my calculator. And again, it's going to be a negative quantity to indicate that the velocity is in a downward direction. So this turns out to be negative 88 feet per second. Velocity is measured in feet per second. Acceleration is measured in feet per second squared. Okay, so this is the formula you'll need to figure out velocities if you know accelerations. All right, folks, let me just comment on a few other examples. Here are some examples of just working out a definite integral. So you remember that when you want to find the exact area under a curve, the area is equal to the integral from a to b of the function dx. So in our example, all we have to do here is work out the integral from 0 to 4 of x to the third dx, right? They're giving us the lower bound is 0 and the upper bound is 4. So I can easily work out this integral. The integral of x to the third is x to the 4 over 4, because I remember the power rule for integration, which says that the integral of x to the n dx is x to the n plus 1 over n plus 1. And I have to evaluate this from 0 to 4. So this is going to be 4 to the 4 over 4 minus 0 to the 4 over 4. Remember, the way you evaluate a definite integral is first you plug in the upper bound, then you plug in the lower bound, and you subtract the two results. All right, well, if I work this out, this is going to work out to be 64, I think. And back here, of course, this is 0. So this area works out to be just 64. All right, so this should be familiar to you. We've talked about definite integrals in Module 7. So hopefully you can work through these kinds of questions successfully. All right, let's look at a few more. All right, well, the remaining questions are going to ask you to find the area between two curves. Notice here it says find the area bounded by the graphs. Well, what this is asking you to think about is, let's say you have two functions. I'm going to call this y sub 1, and I'll call this y sub 2. So you can think of it as a top function and a bottom function. And let's say I want to know this area between, I'll just say x equal 2 and x equal 5, let's say, to just make up an example. So I'm really asking you to figure out this red area between these two curves. Well, it turns out to find the area between two curves, you set up a integral. So this is going to be the integral. In my example, 2 to 5. And you take the top function and subtract the bottom function. So in my example, this would be y sub 1 minus y sub 2. So you have to know the top function. You have to know the bottom function. You subtract those two functions, and you take the definite integral. All right, well, let's take a look at this example. It says y equals x squared minus 15 and y equals 0. The bounds are between -3 and 0. Now, one thing I've got to know is which is the top function and which is the bottom function. So one thing I could do is graph this. So I'm going to go to Desmos. And by the way, many folks did a very nice job with working with Desmos in the Module 7 discussion board. So that was excellent. Let me go to Desmos here. And I'll put this side by side if I can. And let me go back to the homework. All right, here was the homework problem. All right, so I'm going to graph these two functions. The first function is y equals x squared minus 15. I know that's a parabola, so here's what it looks like. Okay. The second function is y equals 0. Well, y equals 0 is the x-axis. So this is the top function, y equals 0, and this is the bottom function, y equals x squared minus 15. All right, well, I could go ahead and set up the integral. This area is going to be the integral from -3 to 0. And by the way, let's see here. Let's put the vertical lines on this also. So I'm going to come here to Desmos, and I'm going to put x equal -3. as a vertical line and x equals 0 as another vertical line. And so I could see the area they're asking me to find. They're asking me to find this red area between these two vertical lines and between the top and the bottom curve. So I'm trying to find this red area. All right, well, I know I need the top minus the bottom. So the top curve was y equals 0. So I'm going to put that as a 0 minus the bottom curve, which is x squared minus 15. Notice I'm putting this x squared minus 15 in its own set of parentheses. So this is going to be the integral from -3 to 0 of negative x squared plus 15. All right, well, I can work this out. This integral is negative x to the third over 3 plus 15x, and I'll have to evaluate from -3 to 0. All right, let me plug in the top bound of 0. So it's going to be -0 to the third over 3 plus 15 times 0. And then I'm going to subtract when I plug in the lower bound of -3. That's going to be -3 to the third over 3 plus 15 times -3. All right, well, I'm just going to work this out. This first parenthesis is just 0. -3 to the third is -27, but there's a negative sign in front. So that's going to make it positive 27. And in the back here, 15 times -31 is -465. All right. Well, 27 over 3 is 9. And 9 plus -465 is -456, but there's a negative sign in front. So this answer looks like it's 456. So this red area is 456 square units. Okay. So again, the way to set up this integral is you take the top curve minus the bottom curve. So you really want to graph these two functions so that you can visually see which curve is on top, which curve is on the bottom. All right, let me go to textbook. I just want to show you. Let me jump to where this is discussed in the textbook so you can see. Yep, here it is. Area between two curves. So notice what it's saying is if you want to know the area between two curves, take y sub 2 minus y sub 1. Notice y sub 2 is the top function and y sub 1 is the bottom function, and it always has to be set up that way. Okay. All right. And so let's go ahead and take a look at this, and you'll notice here's a nice worked out example down here. In this worked out example, you could see this is the top curve, y equal x plus 2. And here is the bottom curve, which is y equal x squared. So again, I always have to make sure I recognize what curve is on top and what curve is on bottom. All right, let's go do my math lab problem. Let's do one that's a little more complicated. That one is similar to what we just did. Why don't we do, let's do number 6 here. All right. So they want me to find the area enclosed by these two curves. Well, they're not giving me the lower and upper bound here, though. So I'm going to go to Desmos and graph this and see what I can figure out by looking at the graph. So let me do that. Let me put this side by side here. All right, the first function is x squared minus 6x. And the second function is y equals negative x squared plus 2x. All right. Well, I can see this blue curve is on top, right? You can see from the graph that this blue curve is on top and the red curve is on the bottom. So this is going to be the top curve. right? Because the blue was the negative x squared plus 2x. So this is the top curve. And the bottom curve is going to be this x squared minus 6x. So if I want to know the area between these two curves, I have to take the integral from a to b of the top minus the bottom. So in our example, our top curve was negative x squared plus 2x, and our bottom curve was x squared minus 6x. Well, I also need to know the bounds, the lower and upper bound. Well, by going to the graph, I can kind of see the bounds because here is the left bound 0, and here is the right bound 4. So I know this is going to be the integral from 0 to 4. I can also figure out where the two graphs intersect. To find where the two graphs intersect, I could do this algebraically. The way you do that is you just set the two functions equal to each other. So I could set x squared minus 6x equal negative x squared plus 2x. That'll give me the x values where these two graphs intersect. All right, well, let me do this. I'll add x squared to both sides here. That means 2x squared minus 6x equals 2x. I'm going to subtract 2x from both sides now. That's going to get me 2x squared minus 8x equals 0. On the left side, I'm going to factor out a 2x. Now I'm going to set each of these parentheses separately equal to 0. 2x equals 0. That gets me x equals 0 as one intersection point. And I'll set x minus 4 equal to 0. That gets me x equal 4 as the second intersection point. So those are my bounds. And I knew that already because I looked at the graph, but I could figure it out without looking at the graph if I wanted to do it algebraically. All right, well, let's go ahead and work out this integral just to finish this up. This is going to be negative x squared plus 2x minus x squared plus 6x dx. All right, let me work that out up here. So that's going to be, I'm going to erase a little of this stuff up here. By the way, let me highlight the area we're trying to find. Right, we're trying to find the area between the two curves. So we're really trying to find this red area in between these two curves. That's our goal. All right, let me keep going. So this is going to be the integral from 0 to 4. I have a negative x squared and another negative x squared. So that's negative 2x squared. And then I have a 2x plus 6x. That's 8x. All right, let me go ahead and take this integral. This is going to be negative 2x to the 3 over 3 plus 8x squared over 2. And I have to evaluate this from 0 to 4. This is negative 2x to the third over 3 plus 4x squared from 0 to 4. Now I'll plug in negative 2 times 4 to the third over 3 plus 4 times 4 squared. Now I'm going to plug in the 0, the lower bound. And you could probably see when I plug in the lower bound, it's going to be a 0 in this back parentheses. All right, so I'm noticing this back parenthesis is just a 0. And this front parenthesis, let me erase some of this here. The front parenthesis works out to be, let's see, 4 to the third is 64. So this is going to be negative 2 times 64 over 3 plus 4 squared is 16. So 4 times 16. All right, so this is going to be negative 128 over 3 plus 64. All right, well, I probably want to get everything changed to be the common denominator. So let me go ahead and multiply this 64 times 3 over 3. So I'm going to end up with negative 128 over 3 plus 192 over 3. Finally, keep the denominator of 3, and I'm ending up with 64 over 3. So that's my final answer. So this area, this red shaded area, is an area of 64 over 3 square units. All right, folks. So again, when you want to find the area between two curves, you take the integral of the top curve minus the bottom curve. It's always got to be in that order. So using Desmos or graphing calculator is a nice tool to help you visualize what function is on top, what function is on bottom. And you'll also need to know the bounds of integration as well. And then it's really just a definite integral type calculation that you've done quite a bit of in Module 7. All right, folks, hope this is helpful. Let me know if you have any questions as you're working in the Module 9 homework. All right, thanks, folks.